So now we're going to get into functional groups. Functional groups are a way that we classify organic molecules. And specifically, these look at certain structural features contained within a molecule. So we say that they're structural features that allow us to classify molecules. And this organization is important in two main perspectives for us. One is from the point of view of nomenclature. Each functional group has its own method of nomenclature, where you have some small changes within the functional group, but otherwise it's just, the root, the part that actually names that functional group, stays intact. But more importantly, when we talk about functional groups, these structural features are important in reactions. So ketones usually react in the same way when subjected to the same reagents. And the same is true for many other functional groups. And these are things that we'll see over the course of this entire semester. For right now, though, it's just learning the basics. What are some of the most important functional groups, the most common ones, the ones that we need to know? How do we recognize them? What do we call them? And so you will need to know all of these functional groups that we talk about here. You'll need to be able to recognize them if they show up in a structure, and you'll need to be able to go the other direction. So if I said to draw something that contains a carboxylic acid, you would need to be able to draw a carboxylic acid out. So we'll divide these functional groups up into three general categories. Carbon-based, so just containing carbon and hydrogen. We'll have carbon bond single bonded to other atoms and carbon double bonded to other atoms. Now, this is not, and it's not meant to be, a comprehensive list of functional groups. These are the basic ones, the most important ones, the ones that we have to know in order to be able to talk about organic chemistry. So we'll start with the simplest one, known as an alkane. An alkane is a molecule that contains only carbon-carbon single bonds and carbon-hydrogen bonds. Nothing else. And this term alkane we only use in this setting. So one of the things I like to do when I teach functional groups, and I've done this for every single functional group that we're going to talk about, is to actually show you some examples of where we find them. You don't need to memorize these examples. These are just so that you can see, oh, here's an example of an alkane or an alkene, and so on. So an alkane, we've said, is just carbon-carbon, carbon-hydrogen single bonds. And so here are three examples. We have methane that you might be familiar with. We commonly use this as a fuel for heating houses. This is natural gas. Propane, of course, another fuel that is used commonly. And 2,2,4-trimethylpentane is also sometimes known as isooctane, and at times is a major component in the gas that you put in your car. From alkanes, we move to alkenes. Alkenes, which are sometimes known by this, or referred to by this old-fashioned name, olefin. are carbon-carbon double bonds. Now, when we talk about molecules or the functional groups in a molecule, it's very, very common for a molecule to have more than one functional group in it. So we don't say that the molecule isn't necessarily is an alkene, but we can talk about the alkene that exists in the molecule. So over on the right we have alpha-pinene, which if you ever smelled turpentine, that's a lot of what you're smelling. Retinal down here at the bottom, it's what allows for vision. Now you also see it has another functional group, a different one that we haven't talked about yet. We'll talk about that functional group later. And then we have this other molecule up here that has not just one alkene, but in fact has 11 alkenes. And what is this molecule? Well, this is beta-carotene, which of course we know from things like carrots, and that's what gives them their color. In fact, interestingly, it's the fact that beta-carotene has all these single and double bonds that is what gives beta-carotene its color. Anytime we have a molecule that has this pattern of repeating of double bond, single bond, double bond, single bond, if we start putting enough of those together, then that's where we start to get much more colorful compounds from. Otherwise, a lot of our organic compounds are just white solids or colorless liquids. So alkanes are our carbon-carbon single bonds. Alkenes are double bonds. And so you might guess that our next group, alkynes, would contain carbon-carbon triple bonds. Now, of the functional groups that we're going to talk about right now, this is probably the least interesting functional group. And you can probably see that based on the two examples I've chosen. It's actually really, really difficult to find any interesting examples of alkynes. These were probably the two best that I was able to find. Capillin, which is a compound with known antifungal activity. And then this other compound, which I'm not entirely sure how to pronounce. But you can see not only does it have an alkyne in it, it has 3 alkynes. And you can also see it has an alkene in it as well. So this is actually a compound that's used in the Amazon when they wanted to make poisoned arrowheads. This compound got used. The final group that goes into our carbon-carbon, all-carbon group are aromatics. So what an aromatic ring is, or an aromatic compound, is actually fairly complicated. So the simplest example of an aromatic ring is a 6-carbon ring that has alternating single and double bonds. Now, we may talk about in a future part of this course that there are actually many, many other types of aromatic rings, and some of them are extremely important. But right now, today, we're going to focus on this as our aromatic ring, because it is the most important, the most common. And you can see some examples here. There's an aromatic ring contained here in styrene. Styrene, you might be familiar with, is the precursor to polystyrene, or styrofoam. Phenylalanine is an amino acid. That has an aromatic ring. Down here we see Valium, which has not one but two aromatic rings. And we see an aromatic ring here in the structure of morphine as well. Now, before we get off the topic of just carbon-based, there's a couple other pieces of terminology I want us to be familiar with. And that's when we're talking about carbons, we can classify a carbon as primary, secondary, tertiary, or quaternary. And these terms here literally refer to what the carbon is bonded to. So if the carbon that we're looking at is bonded to one other carbon, then that's what we would refer to as a primary carbon. A secondary carbon is bonded to two carbons. Tertiary carbon bonded to three carbons. And then I'm sure you've already guessed at this point that a quaternary carbon is a carbon that is bonded to four other carbons.